Hi, welcome to my channel. In the previous video, we discussed about the main challenge of the machine learning. So, insufficient quantity of training data, non-representative training data, poor quality training data. In this video, we are going to see irrelevant features of the training data. So now, in this video, you can see the irrelevant features of the training data. Irrelevant features is also known as redundant or uninformative features or attributes present in the dataset that do not contribute to relevant information to the learning task at the hand. So that means unnecessary data or redundant data or uninformative data features are present in our dataset that causes the irrelevant information to the learning task. So this is very difficult to train our model. So these features may not have meaningful relationship with the target variable or might have a weak correlation between the different attributes, making them unnecessary for the model to make accurate predictions. So you have to overcome the irrelevant features. So irrelevant features in the model can lead to increase the complexity of the data model, longer training times, and a high risk of overfitting, where the model memorizes the noise rather than the learning the meaningful patterns. So that is a very drawback of the due to irrelevant features in the data set. So properly identifying the irrelevant features in our data set and handling the irrelevant features is the very crucial part of the data in the machine learning. So you have to building a efficient and accurate machine learning models. So this is very important for the machine learning models. So resolution techniques for the irrelevant features. Techniques for dealing with irrelevant features like feature selection. So you have to apply methods like forward selection, backward elimination, or recursive feature elimination can help identify and keep the most relevant features in the data set. And the second approach is dimensionality reduction. So techniques like principal component analysis or tree distributed stochastic neighbor embedding like t-SNE can compress the data into a lower dimensional representation and retain the essential information while discarding the irrelevant features in the data set. That means if a data set contains 1,000 features, these 1,000 features are not relevant for your model. So you have to ignore some of the features by applying the dimensionality reduction techniques. It will reduce all the 1,000 features into 10 features by applying the principal component analysis or t-distributed stochastic neighbor embedding technique. So without losing any information, we are minimizing the number of features into 10 features. So for example, irrelevant columns, including columns in the data set that have no significant impact on the target variable or model's prediction, can introduce the noise and unnecessary complexity. So you have to remove that data. And duplicate features. These duplicate features having duplicate or highly correlated features can lead to skew the model training process and lead to overfitting, where the model memorizes the data rather than the generalizing the patterns. So due to this also you have to get the less performance. So it's important to ensure that the data set used for training a machine learning model is of the high quality and contains relevant features in the data set. So data scientists and machine learning practitioners must carefully analyze the data, clean the data, and pre-process the data before feeding this data to the model. So proper data quality and feature selection can be significantly improve the model's performance, model's accuracy, model's robustness, and efficiency, and resulting a better predictions on new data or as well as unseen data. Thank you for watching our video. In the next video, we are going to see one more challenge of the machine learning, that is overfitting. How to overfitting the data. Thank you.